Now let's see what occurs when data must cross an enterprise network with multiple routers and subnetworks. The process starts the same as the last sequence, but now device A needs to communicate with device C. As device A builds the packet in its IP software, it compares the destination IP address with its own IP address. It discovers that the devices are located on different networks. A is on the 192.168.11 network, and C is on the 192.168.43 network. Realizing this, A knows communication with C requires processing through one or more routers. Each IP station has a local router designated as its gateway. The term gateway refers to the place through which a device gains access to the rest of the network, and in this case, the gateway is a router. Device A needs to send the data to the router for further forwarding. Device A has the gateway router's address because it is normally configured in the software. But while A has the gateway router's IP address, it still needs its MAC address. So A generates an ARP broadcast to get the router's MAC address, just as it did for B's address in the last scenario. Once it gets the first router's address, it sends the data to the router. When the router receives the data, it examines the destination address and consults its routing table. The routing table lists paths to all networks that the router is aware of. This table is built from communication with other routers. Router 1 determines the destination can be reached through Router 2. Router 1 has Router 2's IP addresses and uses an ARP message to get its MAC address, then forwards the packet to Router 2. Router 2 repeats this process and forwards the packet to Router 3. Once Router 3 receives the packet, it determines the destination is in a local network. Router 3 then generates an ARP message using the destination's IP address. Once the router receives the MAC address of the destination, it delivers the data. As you can see, the MAC address changes as it travels across the network, but the IP address does not.